Question number 8. We're doing percentages here. We remember that most percentages allow us to use original value times the multiplying factor is equal to the new value. So, prices are reduced by 15%. That means our multiplying factor will be 0.85. Remember, I've gone down from 1 by 15%. The normal price of a printer is £240, so its original value is £240. What's the sale price? 240 multiplied by 0.85 comes out to be £204. Now that's a nice round number. If you had got a string of decimals, remember, pounds are measured in pounds and pence, so you'd put point and then 2 decimal places and round up appropriately. Okay, in the same sale, which means the same reduction is happening, the sale price is £663. So the original value times the multiplying factor equals new value still holds, but we know the new value in this sale is 663. It's a sale of 15% off, so it's a multiplying factor of 0.85. And we want to know what the normal price is, the original value. Here is rearranging equations, so whatever we do to one side, we have to do to the other. If we divide both sides by 0.85, then we'll end up with our original value left on its own. 663 divided by 0.85, calculator time, £780. Question 9, we're solving an inequality. We treat these just like equations, but we take extreme care if we're going to multiply or divide by a negative number. Let's see if we have to. If we add 3 to both sides, we have 2x is less than 8. Divide both sides by 2, we find x is less than 4. There we go, x is less than 4. N is a positive integer, integer is a whole number, so 1, 2, 3, 4, etc. Write down the values of n which satisfy the inequality 2n minus 3 is less than 5. You'll notice these are equivalent expressions. We've replaced the x with an n. So we need to know what values we can put in for n to make this statement true. More importantly, which positive values make this statement true. Well, if n equals 1, we'd have 2 lots of 1 minus 3. And that gives us an answer of negative 1. That's less than 5, so that's acceptable. When n is 2, we'd get 4 minus 3, which is 1. 1 is less than 5, so that's acceptable. If n equals 3, we're getting 6 minus 3 is 3. That's acceptable. And if n equals 4, we're getting 2 lots of 4, which is 8, minus 3, which is 5. That's not acceptable because it's not strictly less than 5. Now, this is a long-winded method if, for instance, this inequality isn't quite so limited. So really what we could have done is just look at the first part. It's the same expression. So if that was an n there, we'd have had an n there and an n there, and it would have told us that n would have to be less than 4. N would have to be less than 4. Well, hang on. 1, 2, and 3. They're all less than 4. 4 is not strictly less than 4, so it wouldn't have included. Final answer would be 1, 2,